Hello guys, welcome to Eagle Vision, and you're watching this new set of video tutorials that I've just created in a new playlist. And this set of video tutorials is exclusively for those students who are studying in third semester of either computer science and engineering or information science and engineering in my country, that is India. So the next set of video tutorials following this will be about the programs. I'll be explaining the programs which are included in the syllabus of third semester computer science engineering, and I'll be explaining a set of 10 to 12 programs which are included in the syllabus for data structure lab for these engineering students. And follow me on Twitter, and please share this video and subscribe to my channel if you have not done it yet. So if you are not any one of them, any one of the students, so just feel free to go ahead and have a look at the one or more of the tutorials, and you'll get some piece of knowledge that you had not got earlier. Without wasting much time, let's get started with our first lab program that will be basically on arrays. So let's see what basically an array is. An array is a primitive data structure that can hold multiple items of a single data type. So here we have an example array that contains 7 integers. All these values 23, 34, 7, 49, all these values are of a single data type. They are integer values, right? So that is why an array is considered to be a primitive data structure that can hold multiple items under the single name, and all these items are of same data type. So if you want to get a deeper insight of what in-depth arrays are, just go ahead and check my tutorials on a basic C programming tutorials playlist. And okay, we'll proceed with the operations performed on arrays. The basic operations are insertion of an element, and next comes deletion of an element, and then accessing an element. That's basically to display the values present in arrays. Let's see how we can go ahead and create an array of a particular data type. So in this program, we are creating an array of type integer. So, and just for a side note, I'll be putting important points to be noted throughout these tutorials in red font. Just go ahead and read that and understand what it is. So here I've put a note that says resizing of an array cannot be done during runtime if its memory was statically allocated. So that's one of the most important and basic point that we have to note for this program, because in this program we will be declaring an array the size of which will be fixed throughout the program. The size cannot be reduced nor increased. So that being said, let's see how we are going to create an array. So we declare an array first, int a of 100. So this is going to be a global array variable, since we will use this array in multiple functions outside of main. So we declare an array of size 100. Remember that we cannot resize the array again during runtime, and we declare another variable to hold the array size, that will be n. So we write a function to create an array. We'll name that function create, and the return type of function will be void. So if all these things are not making sense to you, just go ahead and check the basics of all these concepts in the other playlist that I mentioned earlier, basic C programming tutorials, and you'll get a proper insight of what these elements in this code are. Okay, we have a local variable I, integer, so that we will use for the for loop. Here we say printf, enter the array size. So what exactly this technique is basically called prompting the user. So whenever you want to take some input from the user, you basically display a message saying enter the input, enter the array size, for example, right here. So that is basically called prompting the user. We prompt the user to enter the array size, and we scan that element or that value and store it in the variable n. Remember, n is the global variable from here that we created to hold the array size. So now n holds the array size. So next we prompt the user to enter the array elements, and we initiate a for loop. The for loop ranges from 0 till n minus 1. That will be I less than n. And an important point to note is that n should be less than 100, because the maximum array size that we created is of 100, and remember I said it cannot be resized during runtime, so 100 is the fixed value. It can be less than that, but it should not exceed 100. We read one element at a time at one position into the array memory blocks. So after this being done, after when this statement is executed, when int a of 100 is executed, the computer allocates 100 blocks of memory with 2 bytes each. So here we can see this is how the array will be, and every element in the array will be initialized. I mean, every position in the array will be initialized to 0 at first, and it also depends on the compiler how positions are initialized. But some compilers initialize the positions with a junk value. So if you're using Turbo C compiler, then every position of the array will be initialized 0 before assigning the values to them. And this is basically our create function. An array is created now. For example, if the input was for the array size was 7 and the elements input are these things: 23, 34, 7, 14, 9, 72, 60, the array will be like this. So it will have the first 7 positions will be assigned with the values entered by the user, and the rest 93 blocks will be assigned 0 or junk value depending on the compiler you're using. And an array element is accessed by its index or subscript. If you want to know what a subscript or index is, go ahead and check the other playlist. So let's see how we can insert an element into the array. We have a variable called the element whose value is 3 right here. And if you want to insert that value 3 between 7 and 14, we can do that by 2 methods. One, we can move the elements on the left by 1 block to the left, or we can move the elements on the right by 1 block to the right. Obviously, we cannot move the elements on the left by 1 block because we don't have any memory space left onto the left here. We start from a of 0, and hence we move the elements on the right to 1 block by right. So the resulting array is going to be like this. When 3 is inserted at this position, the elements that were present here will be moved to the right. So that's how we have to do it. We move the elements on the right to the right by 1 block. So what basically does that is, what we can generally conclude from this is a of 4 will have the previous a of 3, a of 5 will have the previous a of 4, a of 6 will have the previous a of 5. So what that means is a of 4 will have a previous a of 3 here, a of 4 in the resulting array will have the previous a of 3 right here. So that's what happens when we move all the elements, that is the element here to here, the element here to here. So generally a of I plus 1 element will have the previous a of I. So for example, if the value of I is 4, this will evaluate to a of 5, and that will have the previous a of 4 according to the second line that we concurred here. So programmatically, we write a function to insert an element. We name the function insert, and the return type of the function will be void. A variable for the iteration, a variable for storing the element to insert, and we prompt the user to enter the position to insert the element at. We store that in a variable called position. And why we do position minus minus here is basically how we address the positions for our convenience is we say first position, second position, and so on, right? We start from the first position, but programmatically the position or the subscript of an array starts from 0. We say position minus minus, so we can use the variable pos in the subscript. So we prompt the user to enter the element to insert, and we store the value in a variable called element, and we initiate a for loop. That for loop, the iteration starts from n till position. This is because n denotes the element that is here. At this position is the n, a of 7, and why we run the for loop till position is because when we stay here, when we start from here, a of 7, we take this element, put it right here. We take the element at a of 5 and put it right here. So that's what basically does this. A of I plus 1 will have the previous a of I. So when we write a of I plus 1 is equal to a of I, so that will move the elements from the position to the right by 1 block. And then we say a of position is equal to element, that is inserting the element at the given position. And why we write n plus plus after this process is we reassign the n. N is the variable to hold the array size. We reassign the net size of the array to that variable so that we can use the variable to display or read the elements from the array later. So moving ahead to deleting an element in the array. So how do we delete an element in the array? There's nothing called as destroying the value in a memory or anything as such. What we do is we overwrite the element at the given position with its next elements. So that's what basically we do. So here, if you want to delete the element at position 2, what we do is bring 3 to 2 and bring the value at 4 to 3, 5 to 4, 6 to 5, 7 to 6, and 8 to 7. So that's what we do. We don't destroy or unallocate memory for a particular value in the memory. So that's what we do. To delete the element at position 2, this will be the technique. So we move the elements on the right to the left by one block from that position. So after deleting the element at position 2, the resulting array will be this one. So the 34 will not be there, 7 will be here, 3 will be here, 14, and so on. So let's see how we can do that. The actual move is a of 2 will come to position a of 1, a of 3 will come to position a of 2, a of 4 will come to position a of 3, and so on. So let's take a look at the first line. A of 2 will come to position a of 1. That means a of 2 will come to position a of 1 here. So that means we are moving this element to here. And that's what basically is deleting this element. So when we repeat this process till the last element, we will result with this array. So how we can do that is, generally, a of I will have the a of I plus 1, that is the next element. So programmatically, we write a function to delete an element from a given position in an array. The return type of the function will be void. It's not going to return anything. We declare a variable called element to store or later display the value that we just deleted from the array. And we prompt the user for the position to delete the element from. We store it in POS. I told you why we do POS plus plus. And element is equal to A of POS. So we store the element that will be deleted into a variable called element. And we initiate a for loop next. That for loop is going to go from the position till the last element. And you can see here that we have to initiate the for loop, and it should range from the position, that is 2, the position is 2, the position till the last element 7, and that is why the for loop is ranging from position till 7. And this is what we have to write to move the elements on the right to left by one block, and we update again the n variable, the size variable, with its net reduced array size. And then for the user convenience, we display the element that we just deleted using the value that we just stored in a variable element. So here I have written the program for the function we just discussed, and I've given the link to the source code in the description below. Go ahead and download that if you want, if you don't like typing all these things. And we have the create function over here, and we have insert, we have the function to delete. I just named it DEL because delete is one of the inbuilt functions, so we cannot use that, keywords. And we have a function to display the elements of an array as well. And we have the main function here. We have a variable choice, and we have displayed the choices that the user has. One is to create the array, display the elements of an array, insert a given element at a given position in the array, delete an element from a given position from the array, and the 5 is to exit. The fifth option is to exit. So we display the options in different lines. We prompt the user to enter the choice, and we store that choice number in a variable called choice, that is of type integer, and we pass the choice variable into a switch case. So we have different cases here. So if the user gives the choice 1, then it's for create, right? So we call the create function, and 2 is for display, 3 is for insert, 4 is to delete, 5 is to exit. Exit is an inbuilt function that will terminate the program completely. And just in case if the user enters any invalid input like 7 or 8, then we say invalid choice, and we put all this in a while loop, and the while loop will have 1 as the condition, because like 1 states always true. So This will be a kind of infinite loop until the user selects phi, that is for exiting the program. So what basically happens is when the user selects 1, the array can be created. 2 is for displaying the elements of an array. 3 is to insert, 4 is to delete, and so on. So let's see what happens when we run this program. So here we have the program, the output. We have 5 different options here. Let's select one, that is to create the array. It asks me for the array size, let's say 4, and enter the array elements, let's say 1, 2, 3, 4. Yeah, well and good. And next, it again provides me with 5 options. Let's create, display, insert, delete, or exit. Let's select to display the elements of an array. Here we have the elements display 1, 2, 3, 4, and those were the elements that we just put in our newly created array. And next we have an option to insert the element, that is choice 3. So it asks me for the position to insert an element at. We insert at the second position, position 2. So that will be between 1 and 2. Okay, let's enter the element to insert. Let's insert 99, and okay, that should be inserted. And let's again display the elements. Yes, as we inserted, it's 1, 99, 2, 3, 4. Let's delete an element from a position. So we select 4, and it asks me the position to delete an element from. We say position 4. So that should basically delete the element 3 from here. 1, 99, 22, 3. 3 should be deleted, and let's see if that happens. And yes, deleted element is 3. This statement is being displayed, and if we again go ahead and display the elements, we have 1, 99, 22, and 4. And let's select choice phi and exit out of the program. And yeah, basically everything in this program is working. Go ahead and download the source code, study for yourself, and if you have any suggestions to make this source code more better, just feel free to comment it. And also, if you have any doubts regarding the program that I just taught, feel free to comment it and I'll be happy to answer. See you guys again in the next video. Please don't forget to like, comment, share, and subscribe if you haven't done it yet. And I'll see you in the next video. Till then, have a good one.